Logistics engineering is a field of engineering dedicated to the scientific organization of the purchase, transport, storage, distribution, and warehousing of materials and finished goods. Logistics is generally a cost center service activity, but provides value via improved efficiency and customer satisfaction. The end customer can include another process or work center inside of the manufacturing facility, a warehouse where items are stocked, or the final customer who will use the product. Another much more popular derivative and a complete usage of the logistic term which has appeared in recent years is the supply chain. The supply chain also looks at an efficient chaining of the supply/purchase and distribution sides of an organization. While logistics looks at single echelons with the immediate supply and distribution linked up, supply chain looks at multiple echelons/stages, right from procurement of the raw materials to the final distribution of finished goods up to the customer. It is based on the basic premise that the supply and distribution activities, if integrated with the manufacturing/logistic activities, can result in better profitability for the organization. The local minimum of total cost of the manufacturing operation is getting replaced by the global minimum of total cost of the whole chain, resulting in better profitability for the chain members and hence lower costs for the products. Logistics engineering as a discipline is also a very important aspect of systems engineering that includes reliability engineering. It is the science and process whereby reliability, maintainability, and availability are designed into products or systems. It includes the supply and physical distribution considerations above as well as more fundamental engineering considerations. For example, if we want to produce a system that is 95% reliable, or improve a system to achieve 95% reliability, a logistics engineer understands that total system reliability can be no greater than the least reliable subsystem or component. Therefore, our logistics engineer must consider the reliability of all subcomponents or subsystems and modify system design accordingly. If a subsystem is only 50% reliable, one can concentrate on improving the reliability of that subsystem, design in multiple subsystems in parallel. 5 in this case would achieve approximately 97% reliability of that subsystem, purchase and store spare subsystems for rapid change-out, establish repair capability that would get a failed subsystem back in operation in the required amount of time, and or choose any combination of those approaches to achieve the optimal cost vs. Logistics engineers work with complex mathematical models that consider elements such as mean time between failures, MTBF, mean time to failure, MTTF, mean time to repair, MTTR, failure mode, and effects analysis, FMEA, statistical distributions, queuing theory, and a host of other considerations. Obviously, logistics engineering is a complex science that considers trade-offs in component/system design, repair capability, training, spares inventory, demand history, storage and distribution points, transportation methods, etc., to ensure the thing is where it's needed, when it's needed, and operating the way it's needed, all at an acceptable cost.